Hi everyone. Today, grade 11 physics, electrostatics. We are going to answer some questions with you. This is our first lesson. 3 questions we'll try to answer with you. Calculating electrostatics force. Calculating net electrostatic force between charges we are going to calculate. This is our question 1. Before we start question 1, people, you can get in our link, you can get questions. Okay, 3 questions. You can download it and then you can try these questions first and then you can see answers. Please try to answer all questions, get your answers and correct your answers with our video. It is much better for you. All right, so let's continue. This is our question 1. Calculate the net force, net electrostatic force acting on point charge Q3. This is our question. So Q1 is acting on Q3, Q2 also acting force on Q3. We are looking for net acting force. This is our question. All right, let's try how we are going to answer this kind of questions. First of all, we have to remember our formula between forces. If you have 2 forces, what's going to have 2 charges? If you have 2 charges, for example, let's say you have Q1 and then you have distance between these 2. We are writing formula first, this kind of questions. This is our question 2. And force between these 2 charges, F equals, we are using this formula, K times, K is Coulomb's constant. This is constant number, people. K times Q1, charge 1, and Q2 over R squared. So this is our formula. What is K? K is 9 times 10 to the power of 9. You will see in next slide, you are going to see 9 times 10 to the power of 9 with unit, of course. So Q1 and Q2. So, but what about direction of force, people? That's the important point, because when you get direction, you are going to get, for example, if you have Q1 is positive, Q2 is positive, and then you are looking for on Q2 force. So you can say this is F12, as you see, direction to the right. Why? Because you have positive and positive. We are going to use this here for Q2, Q3, Q1, Q3. So we are going to calculate all. And if you have another one with negative, Q1 is negative and Q2 is positive. Now direction is this way. This is your F12. As you see, we are busy from 1 to 2. Okay, because attracting negative and positive, they attract each other, so direction to the left. But if they ask you, people, on Q1, so direction to the left, and force name is F21, from 2 to 1. Is it clear? So, and then next one, so it is negative, that one is positive, attracting each other, so to the right, this one, this is your F21. As you see, from 2 to 1. So you are just labeling forces like this, and then you are using this calculation. And then please remember, R always in meter. Please, you must convert it. And then forces in coulombs. If you see MC, other units, also let's explain them. If you have, let's write all units here this side. We can just, this one 9 times 10 to the power of, this is constant number, always you will get it. So, but these units you have to remember. Let's start with distance between object from centimeter to meter, always, you know, divide by 100. You can get 0.3 meters. You must convert to meter, centimeter, or another unit, whatever you see, you must convert to meter. It is number 1. And number 2, you must convert units to Coulomb. Unit of force, unit of charge must be in Coulomb, and unit of force in Newton. Because when you calculate charge in Coulomb, unit of force in Newton. Okay, let's write Newtons, and Q1, Q2 in Coulomb. If you see this unit, let's start with MC. For example, if you have 1 MC, 1 millicoulomb, 1 times 10 to the power of -3 coulombs. You are converting like this. If you see M, you are writing 10 to the power of negative 3. If you see micro coulomb, 1 times 10 to the power of negative 6 coulombs. All right, please remember these units, because if you don't know these units, your answers will be wrong. You cannot get correct answer. Please remember all, please try to remember all units. So next one, what we have, let's change color. Okay, if you have NC 1 nano coulomb, just like this question, NC equals 1 times 10 to the power of negative 9 coulombs. Sometimes you see PC, pico coulomb, 1 times 10 to the power of negative 12 coulombs. Okay, these points we should know before we answering all questions. First of all, distance in meter, and then charge, all charges in coulomb. If you say another unit, you must convert it. Please use this, milli, micro, nano, and pico, 10 to the power of negative 3, negative 6, negative 9, negative 12. After that, we can answer our questions. If you know these points, it's going to be very easy. K, it's constant number, 9 times 10 to the power of 9. During exam, you will have it. So we can start, we can answer our questions now. Okay. First of all, people, they are asking you for Q3, on Q3. We are busy with Q3. So if you see, if you are drawing Q3 first, this is F13. How we are getting it? First of all, people, just think you have 2 objects, okay, 2 charges. What we have, Q1 and Q3. Just forget about Q2 for now. All right, when you are getting F13. So what you have, positive. And then for this one, as you see, it's also positive. Positive and positive, what we know? They repel each other. So direction F13 to the right. I think it's okay. It's number 1. But we are going to show all forces on Q3 because we are looking for net force. Next one, we are looking for F23. How we are making it, people? Let's draw. Let's think we have only 2 charges. 2 charges, Q1, Q2, and Q3. If you have these 2, what's going to happen now? It is negative. This one is positive. We know they attract each other. So direction this way, F2, 3. And then we can draw this one, or you don't have to draw always, of course, just to understand I'm drawing it. So just use this one. Forget about Q2 first, and Q1, Q3, they're positive, positive, they repel each other. And then Q2 and Q3, negative and positive, they attract each other. And then you are drawing this one, just like free body diagram. You are drawing, and then you can carry on, you can calculate. Okay, what was our formula? K times Q1 times Q2 over R squared and so on. But now we have F13, because from 1 to 3. So Q1 and Q3, of course, we have to use. And distance between 1 and 3, please remember that. So you are adding these 2, all right. So K is 9 times 10 to the power of 9. And then Q1 is 2 times 10 to the power of negative 9. You know, it is N. So when you convert this, 0,2 meters, this one, 0,3 meters. When you add them, you are getting 0,5 for distance between Q1 and Q3. And then Q1 and C, we are converting to C, coulomb, 2 times 10 to the power of negative 9 coulombs. If you want, you can convert this one also, negative 3 times 10 to the power of negative 9 coulombs. And this one is 5 times 10 to the power of negative 9 coulombs. As you see, people, or you will see it now. Okay, let's carry on. So Q1 and Q3 we are calculating first. Q1 times Q3 over 0,5 square, and then you are getting first force. And second one, F2 and 3. F2 and 3, they did mistake here. Let's fix it, let's correct it. So Q2 and Q3 now. So now you are looking for force between Q2 and Q3. K is 9 times 10 to the power of 9. And then you are not using negative here. Please be careful about that, because negative just showing you forces. You are using already here, okay, to get direction of force. So you don't have to put negative this side. All right, just use number. So not negative 1, 3 times 10 to the power of 9, 5 times 10 to the power of 9 over 0.3, because distance between Q2 and Q3 is 0.3 meters. After that, you are getting 15 times 10 to the power of negative 7. So you have two forces with opposite direction. Which one is stronger? This one is stronger. So you are writing F net equals F23 minus F13, because they have opposite direction. Sometimes you will have same direction. People, you should add them. All right. So, and then subtract from each other. So after that, you are getting answer, and the final answer to the left. Why to the left? Because your stronger force to the left. All right. So this is our answer, people, with direction. If they are asking to calculate net force, if they say magnitude of net force, it's fine. You don't have to say direction, but otherwise you have to say direction. Of course, units and everything you must add. Okay, this is our question 1. I hope you are getting it. Let's go to question 2. Today we have 3 questions. This is number 1, but one more time I want to remind you people, please get PDF format from your link. After that, try first, and then you can correct your answers. And then you can get answers and you can correct your answers. All right, let's continue with question 2. Let's see what we have. For question 2, similar question, people, but now Q3 is negative and it is micro. As you see, just changing units and then changing position, negative, positive, as you see, similar questions coming. Okay, let's try calculate the net force acting on point Q3. One more time, Q3. We are gonna calculate. I think we don't have to explain units all one more time. You know already. Let's go to our solution. Okay, first of all, we are busy with Q3. We should know that. If you are busy with Q3, what forces we have? Let's try, let's check. First of all, Q13. Okay, let's check Q13. Just remove for now, forget about Q2 now. Q1 and Q3. Let's draw again. It's here, it's fine. We have positive and then negative. We have positive and negative. Q1 is positive, Q3 is negative. If you are looking for on Q3, you can draw. This is our F13 to the left. I hope it's okay because they attract each other. People pulling, just pulling Q3, and then you see direction to the left. When you want to see Q2 and 3, as you see to the right, why? Because Q2 is negative, and then Q3 also negative, and they repel each other. So distance, let's write distance also. Q1 and Q3 distance is 40 centimeters. 40 centimeters is equal to 0.4 meters. And then Q2 and Q3 distance 0.1 meters because 10 centimeters. And direction to the right. This is our F23. And then we are showing everything on Q3, first force and second force. After that, calculation. So formula is K times Q1, Q3, because we are busy with F13. Just you are using this formula, R13 square. So 9 times 10 to the power of 9, it's constant number. Q1 is 3 times 10 to the power of negative 6. Why negative 6? Because we have 10 to the power of, we have microcoulomb. So 3 times 10 to the power of negative 6 coulombs. Other one also negative 2 times 10 to the power of negative 6 coulombs. If you want, you can convert on the diagram, or you can directly use, but it is best way, people. Just write, convert on the diagram, or you can write somewhere else, but please convert units first. Okay, you are not losing your mark if you don't write somewhere else, but if you write it down everything, it will be easy. Otherwise, you are going to use by mistake 30 centimeters and your all answers will be wrong. So let's carry on. It is negative 1 times 10 to the power of negative 6 coulombs. Okay, we are converting all. After that, using in our formula, Q1 3 times 10 to the power of 10 to the power of negative 6, and then 1 times 10 to the power of negative 6. As you see, we are not using negative here. Why? Because we are using negative and positive just to get direction. When you get direction, you don't have to use. After that, people, next one, F23, K times Q23, one more time, mistake, sorry about that. Q2 and Q3. After that R2 and 3, 9 times 10 to the power of 9. And then Q2 is 2 times 10 to the power of negative 6, Q2. And then Q3 is 1 times 10 to the power of negative 6 over 0,1 square. And then when you calculate, you are getting 1.8 newtons, because we know unit of Newton is. But another point, people, another important thing, because please don't round it off before your final answer. Okay, just use whatever you have, maybe at least 5, 6 digits you can write, it's fine. But don't round it off. If you round it off, final answer will be different. Please be careful about that. And then F23 minus F13, why? Because F23 is stronger than F13. And then direction you can see here, F23 to the right. So when you subtract them, you are getting 1.63 newtons to the right. This is our question 2. As you see, people, similar question, only forces opposite each other, so you can just subtract them. You are using stronger one first, and your final answer, same direction of stronger force. This is our question 2. We have done. Let's continue with next question. If you have any question, please let me know on our comments. Please let me know, and then I will try to answer. I will try to help you. Next question, number 3. Now with angle, so different questions coming. But don't worry about that. It's a similar thing. Only you are not just adding or subtract. You are just using angle to calculate. You are going to use F1 square and then F2 square. Do you remember that one? Okay, let's show that. It is new for you. If you have F1 and F2 with 90 degrees, people, how you are going to calculate it? If you have F1 and then F2, how you are going to calculate resulting force or net force? Oh, sorry, drawing is not good now. So just drawing from this side, this is your FR or F net, we can say. This is your F net. How can we calculate F net? We know F net square equals F1 square plus F2 square. And then you can write F net equals square root F1 plus F2 square. We are going to use this formula. But of course, we are going to say F12 or F13, F23, that kind of thing. So this coming from another option, you will save same answer. Just let's show F2 is here. Without changing direction, you are taking F1 from here and putting here this side. We are using tail to head method also to show F net. F net is here, same calculation. We are going to use this formula to get net force. But after that, other things still same on Q3. We are going to work on Q3. We are going to show F13, F23, and then we are calculating, we are using this formula. Okay, so let's see our solution now. Okay, so as you see, people, as you see our friends, as you see F13, because we are working on Q3 one more time. F13, which direction? Let's get direction on Q3. As you see, it is negative. This one is positive. And then they attract each other. If they attract each other, F13 going up. As you see here, F13 is going up. And then F23, it is negative, it is positive. They attract each other, so to the left. So maybe next time you will see different questions, people, with different charge. For example, if you have Q1 is positive, Q3 is positive. So now force going down because they repel each other. And then if it is positive, other one is positive, they are going to repel each other, so to the right. Or this is left, other one going down, but same calculation, same steps, people. All right, let's continue. How we are going to calculate, just same process. First of all, we are using our formula, F13 from 1 to 3. Force from 1 to 3, K times Q1, Q3 over R13 square, this is fine. And then 9 times 10 to the power of 9, it is Coulomb's constant. And this is Coulomb's formula, you know already that. So 3 times 10 to the power of negative 3. Why negative 3? Because you have MC, millicoulomb. from, let's write all of them. Let's Q1 equals, let's say, negative 3 mc equals negative 3 times 10 to the power of negative 3 coulombs. And then Q2 is equal to negative 2 mc equals negative 2 times 10 to the power of negative 3 coulombs. We should remember what was the m, what was the n, p, so we should remember all. Q3 equals what we have 1 mc. 1 mc is equal to 1 times 10 to the power of negative 3 c. And distance, 30 centimeters. Let's write R13 equals 30 centimeters is equal to 0,3 meters. If you convert them all, just like this, so you will have enough time, people, so you don't have to rush. Please convert them all, and then you can use, and then it's gonna be easy for you. Yeah. And the next one are 2, 3, as you see, 40 centimeters. 40 centimeters is equal to 0,4 meters. Sometimes they can ask you on Q1. So you have to calculate this one also. Same formula, 30 square plus 40 square and square root, you'll get 50 centimeters here, 0,5 meters. But for now, we don't need. All right. If they ask you, this is 50 centimeters. How we are getting it? 40 square plus 30 square and then square root from triangle from formula. You know already that. All right. So F13, K times Q1 times Q3 over R13 square, and then you are calculating it 3 times 10 to the power of positive 5 newtons, and F23 K times Q2 times Q3 R23 square, and then you are calculating it. So which one is stronger? Oh, we don't have to just subtract, sorry, we don't need that stronger one. Only just use this formula, F net square, it's coming. As you see, you can use two options. You can just draw parallel to each other and drawing, this is our F net. Or other option, what we said, just use one is same direction, other one without changing direction, you are taking up, maybe, or you can remove, you can move this 1, 3 also, it's fine, but same thing, you are getting F net. This is our F net, people, coming from this triangle. All right, F13 is here, and then F23 this side. So when you must just use this formula, F23 square plus F13 square, and then you are getting square root, of course, finally, and then you are getting 2 times 10 to the power of 5 newtons northwest. Direction, as you see here, direction, you can draw and see direction to make sure. This is our question 3, people. I hope you are getting it. Please don't forget to convert them all. Charges in coulombs and distance in meters, and calculations, we have different options. You will have, maybe they will have opposite direction, F13 and F23. Maybe you will have same direction. We did answer that kind of question, but maybe you will see next time. So you will see same direction, 1, 3, F2, 3. If they have same direction, you are adding them all. If they have opposite direction, strong one first and minus other one. So if you have with angle, so using this formula, what was our formula? Let's write one more time. F net equals square root F13 square plus F23. Done. All right. So we are going to carry on with more questions. Now lesson 2, electrostatics, lesson 2. For now, we have done. If you have any question, please let me know. I will try to help you. Thank you very much. See you next lesson.